This is House Planning Help, episode 393. Hello, I'm Ben Adam Smith, and this is the podcast for you if you're interested in self-build or retrofit. I'm exploring what houses we should be building in the 21st century and trying to break down the major roadblocks that may get in our way. Coming up in this session, I have two guests for you from Arbor Architects. That's founding director Elly Deacon Smith and associate Kirk Rushby. We're going to be exploring the embodied carbon of our projects. How important is it? And as an architecture firm, how does it fit into their processes? Just before we get started, I've got some important news for you about the Hub. This is our membership community. And after a decade of running this, I've decided it's time to close the doors. It's not been an easy decision to make, although the flip side is sometimes it's the right decision. And I'll go into more detail at the end of this podcast as to some of the reasons. One thing I must do, though, is to thank everyone who's been a member over the years. Whether you just checked in for a month, because I've always said you can get a lot of value for a month or many years, which has also been true of a number of members. And it's been so exciting when people get to the end and I see those photos and think, wow, well done. Another fantastic project has been completed. So yes, we'll talk a little bit more about that later on. Let's get to my featured interview with Elly Deacon Smith and Kirk Rushby from Arbor Architects. We're discussing the importance of embodied carbon. I started by asking them to tell me a little bit about their background.
So I have been an architect now for nearly 25 years. I started practicing in Bristol for White Design, who had a major focus on both embodied and operational carbon. So before it was mainstream, we were building out of straw and timber and doing things that were seen as quite radical. And then when I had children, I moved back to Herefordshire, where I grew up, and started working for Archetype, who obviously had much more of a focus on passive house construction. So that's where I really developed a kind of knowledge of building physics and low energy design. And then when we founded Arbor Architects, we kind of took a lot of that learning and have carried it on in probably on slightly smaller scale projects, much more focused on the domestic sector than perhaps previous practices had been.
And for me, I've sort of been in practice for probably around 20 years, qualified about 15. Most of those were spent at Archetype, where I started around 2006 as a young graduate, and again working. Elly's given the background of Archetype, very kind of sustainable focused, low energy, low embodied carbon and natural bio-based materials generally. And again, brought a lot of that learning. So we've got a familiar kind of similar background really that Elly's kind of encouraged bringing here, and I brought as well, I think, a little bit.
And Elly, what is it like when you set up your own practice? You've done it all before, but then you're the boss. You're in control of all the decisions.
Yes, it was incredibly exciting because you suddenly have this autonomy that maybe you haven't had previously. You get to decide which projects you take on. You get to decide the focus and the direction. But it obviously also comes with added responsibility, and you realise that the buck stops with you. And suddenly you've got to do other aspects of management, people management, which perhaps you had left to somebody else previously. So yeah, it has been a shift in what I do day to day. But the nice thing about running such a small practice is that I can still remain very much involved in project running and in the design process, and I don't have to spend all my time on kind of management and administration.
What's quite nice from a relatively new employee's perspective is that Arbor's a sort of like close-knit team. There's essentially 5 of us. Decisions are made very collectively, even though basically the buck stops with Elly, because Elly's director. She's kind of very open about decision making, and we're all sort of like involved in that very sort of much, which is nice. And I think we also feel quite nimble, which is quite a nice way to be. I think if we want to change tack or we need to do something to improve, it feels like it happens quite quickly, and we just resolve things very quickly, which is nice.
And I've been to one of your projects already from Lucinda Leach, and
yes.
she spoke very highly of you, which is probably one of the main reasons I'm here anyway today. So.
Oh, fantastic. Yeah, that's a really lovely project. And what an inspirational client she was. Very much involved in the design process, and then obviously through the construction. Her and her very able children got involved with building so much of it, from the foundations to hours of setting out timber shingle cladding. It's an absolutely incredible project.
Now, we're here today just to try and find out more about how your thoughts around decisions on embodied carbon, and we've mentioned Passive House and the process behind that, but we're just interested in how this has evolved in your own practice, and particularly maybe you could tell us about a couple of projects that you decided to go back to afterwards and look at embodied carbon.
Yeah, so I think really this started, our focus on embodied carbon started when we formed Arbor Architects. We obviously had this very strong background in operational carbon, passive house construction, but we were really aware that that only tackles the carbon that a building uses when it's in use. And actually, the decisions we make as designers about how the building is constructed also have quite a big impact on the overall carbon impact of that project. It was actually through taking on and leading a master's course at the Welsh School of Architecture in Cardiff, we were able to do more in-depth reading and research around the topic. And we started off by just trying to think in carbon, so just improve our carbon literacy. And it was actually the book How Bad Are Bananas that was a really kind of accessible way of trying to understand the effect of a decision that you might make, sending a letter over an email, for example, or right back to, should you use timber or stone in a building. So that's how it really started. And what was interesting is, I guess, because operational carbon is regulated, there's much more data and it's much easier to model and predict the operational carbon impact of your project. But actually finding data and measuring data on embodied carbon is a little bit more tricky, because you find people are using different metrics, and we had to sort of do our own legwork there. We knew that because we've always had an approach where we prioritise using bio-based materials, that our projects probably were inherently lower carbon, perhaps, than your more standard approach to material selection. But we didn't actually know how our buildings were measuring up. So it was when we were doing an awards submission, actually, and we had to put in the carbon data for our project, that we decided to get them measured retrospectively and actually work out what the figures were. So we chose to measure two projects. One was an Enefit project. It was originally a curtilage-listed set of barns that the client had bought with planning permission to turn into a dwelling. So it was quite a challenge technically to achieve the Enefit standard and get the level of thermal bridge-free construction, the air tightness around a retained steel frame structure. But we were able to reuse a lot of the materials on site. For example, there was a lot of bath stone walls that were all reused. We inserted a timber frame into the original barn structure and fully filled it with recycled cellulose insulation. And then we used a lot of timber-based products for the internal finishes, like troll deck on the roof. And when we got that measured, it came up at about 347 kilograms of carbon per metre squared, which is well inside the RIBA 2030 target, which was great. We also then got our Crumbarn Garden Room Annex project measured, which was slightly smaller than the Tin Barn project, but was clad in zinc because of the exposure of the site. It's still a timber frame construction, but entirely new build. And that one came out at just over 600 kilograms of carbon per metre squared. And interestingly, one of the things that brought that up by about 100 kilograms was actually the PV array on the roof, which really kind of supports the notion that a fabric-first approach is the way to go, because obviously you want to be limiting the amount of PVs that you have to attach to the project to make it work.
Were there any surprises within that assessment?
One of the surprises was that the decision to clad the garden room in zinc didn't have as big an impact as we thought over cladding it in timber, which is what our normal approach would be. But actually, because I guess the size of the project, actually it didn't have a big impact at all.
And how were you doing this? How were you making this assessment?
So for this one, we actually engaged an external consultant who modelled these projects in pH ribbon, so did quite a detailed carbon assessment for us. It wasn't something we could do in-house. But I think going forward now, we're really keen to be able to model in-house and to be able to make decisions quite quickly about the choice of materials and the impact that's going to have. So that's actually something Kirk has started looking at.
Yeah, so recently we've been in contact with Studio Bark, another practice, and they've developed a very kind of simple tool that helps you measure your embodied carbon directly targeted at smaller practices. So we're part of a group of practices kind of helping them to get through that sort of beta process and improve the tool essentially, and using it on a couple of projects to very much through this sort of early design process to inform the designs really, which is a brilliant tool to have because most software of that type is very complicated, very complex with big subscriptions and needs a lot of work, which isn't really targeted at smaller practices who have smaller projects and need a kind of more simplified workflow really, which is where this one sort of comes in really.
So pH ribbon, which was how the other ones were done, so it takes the information from PHPP, and then what additional information are you having to give on top of that? Because that will have quite a lot already.
Yeah, so we had to provide all the information about the construction build-ups, so the quantities of each element within that build-up. So we were providing areas of walls, areas of floors, areas of roof, and then all of that was input into the model, and they could quite accurately then assess how much of each material and then what the embodied carbon impact of that would be as an overall figure.
And how are they doing it at Studio Bark? What will change?
It's a very similar process, but because they have pre-loaded tools, we can essentially just, from a Revit model, take volumes and areas of the appropriate elements of construction, so walls, window areas, and the sort of foundation volumes. Essentially, you can get that data quite quickly from the models we've already got, input it into that tool, and it gives you quick feedback. And then you can change construction types and see what effect that has. So, for example, you could change a wall to timber, see what effect that has. You could change the roof cladding material, see what effect that has. And essentially because the data's all there, it's very useful.
Yeah, you see, that's quite interesting, isn't it? That you're talking up front when you start saying change all this compared to the modelling of, it's very interesting to know afterwards, but there's not much you can do about it then.
Yeah. And it is. So in the past, one of the things I found having used those tools as well is that essentially the amount of information, the level of information you have to get to in order to get an assessment and then give it to someone. They've got to do their assessment. You're going back and forwards with essentially them querying some of the areas or the volume, saying, what about this information? It takes a bit of time to then get that data back. So what you want is the data quick, so you can make a decision very quickly, so that you can make the right decisions early. And it's important to have that kind of information, really, because I suppose, like Elly's saying, we've done a lot in the past where you're using your instincts to try and make good decisions, and that gets you so far. It is actually incredibly useful to have a certain amount of literacy to understand the kind of wider impacts of the decisions you're making, so that you can make good instinctive decisions. But going that extra level and using data is very useful. But the downside of that is sometimes is just the process and the time frame it takes to get that data back. So what you want is both. You want the best of both worlds. You want quick data and to have the decisions made early, but have it as an intuitive part of the design process.
And that's a little bit like PHPP, isn't it? When you're going, do I want this window size or this? And you're seeing immediate responses as to how it's affecting the energy model and so forth.
That's right. And sometimes it's not just knowing whether a decision is good or bad. It's like Elly was saying, it's knowing how bad. So you've always got to weigh that decision up against other factors. So, for example, in the zinc example, you might switch out timber, swap the zinc in, and it has a bit of an impact, but then you've got to say, okay, there's a slight impact there, but maybe there's improved weatherproofing for the project. Maybe it's more robust, more resilient. Whereas if the data comes back and tells you it's quite a big impact, then maybe you make a different decision. And that's why it's quite important to have it.
And is this something that you would do from time to time and, you have to get on with life at that point? Or could it, as we're saying with this new simplified model, be part of your processes?
I think it needs to be, and that's what we're pushing for. I think we have established this way of thinking about our buildings now in layers, and so elements of your building that are likely to be there for a very long time, there might be a very real reason why you need a slightly more carbon intensive material in that situation. But elements of the building that are going to be changed more frequently, for example, internal walls that might be knocked about by, a new owner of a house, those things perhaps need to be lower carbon impact because their lifespan is not going to be quite so long. So we're always, as designers, thinking about that in terms of our material choices as well. We're trying to make sure that we're not using unnecessary embodied carbon in elements that are likely to have a short lifespan.
Now, for someone who isn't doing all this research, can we give them any tips if we break it down, looking at the various stages and so forth? I can make some guesses of where the embodied carbon might be worse, but as you look at a house, what would you flag up that we should be aware of if we're not doing any modelling?
Substructure probably comes up the most, and that, again, that's one of those that it's, as an architect, you can be quite detached from because that's a structural engineer's responsibility primarily, but it does have a big impact, and it can be quite frustrating sometimes when the carbon footprint of a substructure is so big that you're trying really hard to make good decisions on the element you've got control of, and so you kind of have to understand the impact of that and how you can help that situation. Sometimes it's not just take one thing out and replace it with another. So, for example, masonry has high embodied carbon, but on top of that, it's heavy, so it's going to increase the foundations, and that's going to have an even bigger impact. And so you've got to use your instincts as well to try and help make good decisions about things like that as well.
Anything else on foundations?
Yeah, I mean, it's very difficult to avoid concrete in foundations. There are ways you can. But of course, concrete is, by its nature, very high embodied carbon. And so we are always looking to minimise that. And increasingly, we're starting to look at piled foundation solutions, which bring us away from concrete. Obviously, if you can avoid the use of steel in your construction methodology, then that is very beneficial. I guess our approach, we tend to use timber almost exclusively, whether that's timber frame. We also, on bigger projects, use CLT. But, if you can keep your structure, from a bio-based material that has stored carbon as it grows and locked it into the structure, then, you're reducing your overall carbon impact. I think then it's a case of trying to avoid plastics as much as possible, and big elements such as your windows and doors. Again, if you can use timber frames, we often use composite frames, so they're timber on the inside and then they're just faced in aluminium, which then really helps with their longevity and the level of maintenance that people would have to undertake through their lifespan.
One interesting thing with houses exclusively is that if you're building your own house, you're very rarely going to go beyond 3 stories. And so whenever in the past I've had conversations about what's better for a particular project, is it sort of like concrete, timber, CLT, steel? Usually you're talking about bigger projects with larger loadings, much more intense requirements, things like medical projects, schools, things like that. With houses, you've very rarely got a scenario where timber's not going to do the job because the rooms are smaller, you're not going above 2-3 stories. So really, you should be able to stick with sort of bio-based materials.
So what circumstances might you see a steel? Is it when you've got big open spaces? Are there any other key ones like that you can just try and avoid by clever design?
Often you get pushed towards using steel if you're space restricted, particularly where you've got large spans and you're trying to support, say, an upper floor in timber. You can end up with quite deep timber beams, which, if you're restricted for space, can reduce your internal head height. So sometimes in those scenarios, you might be pushed towards a steel beam, which would, have a much more slender profile and therefore give you the head height you require internally. That does happen on some of our projects, and where that does happen, you're then just minimising it to that area in particular and creating a kind of hybrid structural solution where you're using timber wherever you can and you've maybe just minimised your steel to where it's needed.
Yeah. And then the other major element is just the external wall fabric. It's a large area, it's a very thick build-up, and roofs as well. And you compare it, say, timber to something like masonry, the carbon impact is both significant on that element, but also it's a large area of the building. So it's kind of like those areas where there's the most amount of that stuff, which is essentially structure, walls, windows, essentially, and roof.
We're coming back a little bit to the intuitive stuff, aren't we?
Yeah, yeah.
You mentioned as well about the cladding and having modelled that. That was quite interesting. But what else might we have? Because you can't always have timber for planning reasons and fire reasons, can you?
No, you can't. And I think that if you're going down the route of cladding your building in metal, and that could be standing seam zinc like our Kumban project, or even a sort of crinkly tin, particularly in agricultural context, that becomes a cost-effective material to clad your building in. But of course, metal by its very nature is high embodied carbon to produce. So I suppose alternatives that might be lower carbon would be things like stone, which you can often quarry locally. Brick is fairly high embodied carbon because of the firing process of the clay. So we don't often specify brick on our projects, but it's usually a palette of natural stone, timber where we can, and very occasionally a metal cladding.
I suppose in the case where you know, like you were saying, sometimes you have planning restrictions that kind of push you down a certain route in terms of material. So, for example, in the case of brick, the best thing to do is try and use less of it. And one way of using less of it is to try and, say, use terracotta tiles or something like that, which is the same material but more lightweight, and there are loads of different options for that. So you can use a very kind of exposed tile, which looks much more like a clay roofing tile. You can use a type of slip where essentially the profile is designed very specifically to look like brick. You can use a much larger format terracotta tile, which has the same kind of material effect, but has a different aesthetic to it. So I suppose in every case there probably is a lower carbon option, I suppose.
And what about clients? Are they pushing this agenda, or is this really happening behind the scenes?
I suppose one thing that feels quite lucky is that even though clients aren't pushing it centrally, it does seem to be that we are being approached by clients because they would like a more sustainable project. So
I'm thinking back to Lucinda.
Yeah, exactly. So I suppose we're quite lucky that the clients have that, not necessarily driven specifically by carbon, but by wanting a more kind of natural bio-based or project that's sustainable in other ways. And that makes the conversation about carbon a little bit easier because they're more open to it, I guess.
I think that's what's nice, actually, is because our approach to material selection isn't purely based on embodied carbon impact. It's also based on building physics. So we're thinking about the breathability in terms of moisture of the building fabric. We're also thinking about the health of the building occupant and the effect that material choice has on the internal air quality. And lastly, we're thinking about aesthetics. We're thinking about how materials age over time. We're thinking about their tactility and their effect on the people who are using them. So we want our spaces to be healthy and inspiring, principally, and we also want them to be low carbon and to have a minimal impact on the environment. So we're thinking about materials from a lot of aspects, and actually then when you're having conversations with clients, it very much leads you towards a palette of bio-based materials that kind of hit all these key points, and it then becomes relatively simple to persuade clients that that's the route to go down.
I mean, we're just having a conversation about, sometimes it's thinking about it, I guess, multilaterally, so thinking about the implication of one decision on another aspect of sustainability. So you've got every decision you're making, you've got to think about whether it's going to have a carbon impact, whether it's going to have an impact to the well-being of the individuals, be it the air quality, and also there's the impact on the way the building feels itself. I mean, we just had a conversation with a client about PVs. They want PVs, but they don't want their roof to be completely overwhelmed by them. They're concerned about the aesthetic, and it's really easy to. There's a really easy argument there. If you kind of reduce the energy, then you can, like Elly was saying, you can reduce the amount of PVs, and it has other benefits. I suppose there's an opportunistic side to it. I think sometimes it's quite good to think about where the opportunities are on a project, not just the constraints.
And how does cost fit into this? We've talked a little bit about how this is all balanced, but do you ever get to a situation where it is tricky because you can't have everything?
We tend to be quite upfront with our clients right from the beginning about the fact that building to very high levels of insulation and airtightness, and particularly to passive house standards, will come at a slightly increased cost just because you are using more materials in a higher performing way. So we start the conversations very early doors. We understand their budgetary constraints, and a lot of them do have fixed budgets, and then we're designing to those budgets. And that might mean that we're having to kind of steer them to think about the size of their projects, principally.
Well, I was just going to mention, Kirk, one thing that always stuck out from your own project was how you explained the cost thing of going through the whole process and working out all the numbers and then realising you couldn't afford it and to go back to the beginning. So, how do you get that right without your client having to continually pay to go through the design process again? It must be a tricky balance.
Well, it's particularly difficult at the moment because the way costs are in the market, it is very difficult, and you've just got to have that conversation as early as you possibly can. And quite often clients have specific budgets, and we've got to talk about the fact that that's got to be spent in the right way, and that's not always square meterage. More square meterage isn't always better. It's more space to look after, more upkeep of something, really. So sometimes actually you can get more out of less, I suppose. It's just sort of, how can we design the building itself to be more efficient? I mean, a lot of buildings or even houses can be somewhere around 200 square metres, but sometimes when you think about it as an individual, how much space do you really need at any one given time? And it's kind of, how do you use the spaces better so that they can transform? Can one space be used for more than one thing? In which case, can the design of the building be a little bit more efficient? And then essentially you can make it more cost effective and reduce the carbon.
And how would you like to wrap up this interview, either with repeating something that we've already mentioned that's important, or something completely different that we haven't added into our conversation?
I suppose that carbon is one element of a complicated sustainability puzzle that also includes the needs of the client and efficiency and energy, the air quality and the biophilia of the spaces, so kind of how the spaces feel, how they improve your mood. There's biodiversity. There are so many aspects to it. So really, carbon measurement tools are just one element of a very sort of complex puzzle of sustainability, really.
Yes, and I think as designers, we have all become quite good now at understanding operational energy of our buildings, partly because, the building regulations have got better and we're all obligated to make our buildings higher performing. But I think just understanding the climate emergency we're in, we actually have to stop expending so much carbon right now. So that brings embodied carbon to the fore, really, because we can plan our buildings to be lower carbon over their lifespan in the future. But actually the carbon we're expending today to build or retrofit our buildings needs to be at the forefront of our minds, particularly as designers advising clients about these decisions. So I think that's really why, as a practice, we're starting to really focus on this now, because we're aware that there is less knowledge and understanding in the industry about this, but we think that needs to change. We need to start talking about it more. We need to start sharing the data that we can collect on our projects, and that's going to help inform other people about the carbon impacts of certain decisions. If there's more data available, we can make these decisions quicker and in a more informed way.
So does that get shared anywhere? We talked at the beginning about your tin barn and so forth. Did that get shared anywhere? And are you able to have a look at other practices, embodied carbon modelling, and learn so you can keep the learning going?
Yes. Our data got shared through the RIBA awards process, so it was published quite widely and there were various blogs written about it. I think it's great now that when you do submit your projects for an award, whether it's RIBA or an AJ award, they require you to submit your embodied carbon data and your operational carbon data. So I think that's a really good way of looking at projects that have been published and have received awards and understanding then what their carbon impacts are.
I think there's definitely still improvements to make as well in the whole process. Measuring carbon is very useful, but that data and all of the kind of inputs behind it is very sort of complicated. And I think there's things like particularly kind of how energy is generated and how electricity gets generated that is changing over time, that is changing the data. And so it's actually quite difficult to kind of know the difference between what a good decision is now and what a good decision was 5 years ago, and they kind of look different purely sometimes because of site things or because of how carbonised the grid is. So somehow it needs to be simpler. So the measure is exclusively about how good the design decisions were on that project. And I don't know if it's there yet. I don't know if there's, that measurement standard is there yet.
What about regulation? Can we ever see this happening, like in France, that they have a 50% quota for bio-based materials?
Yes, I think it needs to happen. Whether or not it will in the foreseeable future is another thing. But I think we have to push from the ground up. Really, we have to start measuring our own projects because we want to, and we want to understand the impacts of them. And I think again by sharing that, we're going to be helping others make those decisions.
Elly and Kirk, thank you very much.
Thank you.
Thank you.
Head online to take a look at the show notes that accompany this session, houseplanninghelp.com/393. We've got some photos of those projects that we've been talking about. You can also check out the summary and dig into the key points. Maybe you've got a comment or you'd like to ask a question. Well, we always encourage you to get interactive on social media, so we'll have links there as well. Links, of course, to Arbor Architects. Also, a sneaky link to Kirk's own self-build project. We covered that in a podcast a few years back. And a lot of the same messages that we've heard today, plus one of simplicity. So what's all that about? You can dive into the archive. houseplanninghelp.com/393 for all of that. So at the beginning of the podcast, I made an announcement that the hub is going to close after a decade. It's been a lot of fun. It's been a lot of work. And probably today, the question I'm going to answer is why? Why are we closing this? I think for a membership, you do need growth. And this is probably still a small market. A couple of times I said to myself, I can turn this around. I can do it. And then I couldn't do it. So I do think sometimes you've just got to know when to quit. And now is the time to quit. I also wonder whether there might be something at play with Google, because we've always ranked really well because of our content. And these days, they're less search engine and more answer engine, aren't they? So instead of referring you to websites, they like to do the whole thing, answer your questions so you stay with them. I understand it, but it doesn't really help at this end. Also, running a membership community is a lot of work. There are many plates to spin, and I think I've had a few smashing plates on several times. I've given it my best go, though, and we've tried to cover all the main bases. It's fascinating, I suppose, because building a house is such a big topic, how many specialist areas there are. And quite often there would be questions on something very precise where I'd have to refer people on because we just couldn't answer those things. But I did like the membership model from the point of view of having this vault, having this archive of ever increasing information. So it was useful sometimes to be able to say, well, go and have a look at this section here. This has cropped up before. And that at the beginning was why I like this and why I thought I might even refresh my own memory one day because we will have recorded this section here or that over there. So that's pretty much the deal. I'm sure we'll reflect on it a bit more in the coming episodes. But I would say a massive thank you to all the members and also a massive thank you to everyone that's given their time, the experts to come in and teach something or contribute in some way. There we go. The end of another podcast. Thank you so much for listening. The House Planning Help podcast is produced by Regen Media, content that matters.